For the ending of 5.4, we start to see a lot of synthetic division, and I think that the end part here really sells me personally as to why synthetic division is so great, so convenient, and makes my life a lot easier when I'm dividing polynomials. So for this, it's a little wordy, so let's recall the Ridges problem-solving method, or if you need a refresher, but you probably have this memorized, right? We're reading the problem. We're going to interpret, at least for the first one. We'll draw this out. We will make a goal. We'll make an equation if possible. And we'll also continue to solve. The last two, we might not actually need an equation, but it's good to keep in mind that that's what we're asked to do if we're working with this problem-solving method. So this is kind of allowing us to run free with synthetic division to solve this problem where we have a polynomial x cubed plus 9x squared plus 23x plus 15, which is expressing the volume in cubic inches of a box. The length is x plus 5 inches. What are the other two dimensions of the box? So of course, when you go to IKEA or you've ever ordered something from Amazon, the box is most likely not going to list dimensions that are these polynomials, but this is kind of a fun word problem to work through. So I'm pretty confident I understand what it's asking. As a refresher, the volume measures how much can be filled in this box. And the way that we can express volume is by taking the length times the width times the height. So I'm kind of tying in a drawing to this already. I know that this polynomial is important. I know that the length is already x plus 5 inches. But notice that I do not have the width or the height. And we know that the total volume needs to get us back to here. So as mentioned in the previous video, if we have our length of x plus 5 going for the root of this, that's the one that we need. We can solve for the root pretty quickly if we solve for what x would equal as far as the 0 goes. So since negative 5 is important, let's put negative 5 here. Put in our polynomial using our coefficients from left to right in ascending order of 1, which is unwritten. But if we write it in here, now it's unwritten. The unwritten now becomes written. We have 9, we have 23. And 15, wonderful age. You can almost drive at this age. Most of you are 15, so cool. As mentioned from previously, we drop down that first coefficient. We drop it down like it's hot. So drop that like it's hot. Taking the product of negative 5 and 1, we then have negative 5. 9 minus 4 gets us, 9 minus 5 gets us 4. Negative 5 times 4 gets us negative 20. We also have 23 minus 20, which is 3, negative 5 times 3, which is 15, and that's negative. So notice we have a remainder of 0, but now we have to kind of pick back or peel away these terms here and say what the product of the width and the height are. So if we go from right to left, we know we have a constant of 3. We have a coefficient for x, which is 4. Our coefficient for x squared is 1. So this is saying that x plus 5, when multiplying with this polynomial, should give us the volume. And I kind of went with the idea that I needed my 2 dimensions, and I kind of stated that verbally, but as our goal, we're trying to get the width and the height. So this is our goal. We see here that we only have the product of the width and the height, but focus in on this one real quick. This polynomial seen here. Does this look like something we could rewrite? Hopefully you're saying yes. This definitely looks like something we could factor. So if you need to use diamond method, do that, but this one's pretty easy. 3 is prime, the sum's positive 4. So when we factor this, we could say that, and we're not too sure on which one's which, and we're lucky that we don't really need to know, that one of these is going to be the width, one of these is going to be the height, because when we rewrite this, we end up with two factors. So one of these can be the width and the height. I'm not too picky on which one. There's no real way to decide on which one's which. But we can say that the width is x plus 3, the height is x plus 1. So those are the two dimensions that we're missing. I'll give you a moment for the next problem. So pause it, give it a shot. If you get stuck, look at the work here. But you should be taking a root of -1. You should be using coefficients of 1, 6, 11, and 6. Drop that 1 like it's hot. Got 1, multiplying, getting rid of 1. 6 minus 1 gets us 5. Minus 5, leaving us 6. Minus 6, getting us here. So we know that x plus 1, when multiplying, picking back the pieces up from left to right, or sorry, right to left, constant of 6, adding on 5x, x squared leading the troop. Notice again, this can be factored. So get that going. Our product is 6, our sum is 5. The only factors that make sense here are 2 and 3. So collectively, x plus 2, x plus 3. Let's call this our width. Let's call this our height. Not the worst word problem in the world. There are only so many word problems you can throw in with synthetic division, but I think these ones are pretty manageable. And we also see, finally, one of my favorites, which can be really astounding if you really want to blow some people's minds and see what the outcome is for a polynomial when it's evaluated for some number. Seen here, this is a lot, but we'll soon break this down. So if we divide a polynomial, p of x, of a degree n, so pretty much saying if the leading degree is greater than 1 or equal to 1, and we have this set up here, then the remainder is going to be that very last evaluated function, and that's going to be the value. So if p is 4, we're evaluating that on the outside, listing our coefficients of 1, 6, 9, 3, -3. Drop that 1 like it's hot. 1's here, adding on 4. Where I see students trip up here is with arithmetic. Take your time. If you mess up one of these, it messes up the rest of them. 6 plus 4 gets us 10. Add on 40. 40 and 9 gets us 49. Getting a little big with the arithmetic here now. So 4 multiplying with 49 gets us a whopping 196. Adding this on gets us to 199. 4 times 199 is going to be 4 less than 800, so 796. And if we take this further, 796, but taking away that 3, 793. If you're not convinced, if we take a look at a calculator and we decide that we want to plug in for everything that we have here, notice we'll have x, we're cubing it, we're then using 6, but we're adding that on, of course. 6x, cubing that. Sorry, x to the 4th plus 6x cubed plus 9x squared. We're adding on 3x. We're taking away 3. We'll see the graph and see if there's anything noteworthy from it. Since we've talked recently about end behavior, as we see here, it's kind of going up pretty quickly. So we can hit second, trace, we can hit value, we can type in for 4, and lo and behold, when x is 4 for this polynomial, the outcome's 793. Lovely stuff. Wow, your friends. I'll give you a moment for the next one. Pause it, make sure it looks good. Your work should look like this. notice we're not skipping any coefficients. Occasionally, if one of the terms is missing, just put in a 0 as a placeholder, but this is going sequentially, or is it? What term are we missing? Missing x squared. What an upsetting thing, we're missing x squared. So let's just leave in a 0 as a placeholder, because we still can do this even though x squared is missing. So think of this as 0x squared. We have 5, and then we have 20. Back to the normally scheduled synthetic division, evaluating. Drop that 1 like it's hot. -3 minus 4, -7, drop it like it's hot. -4 times -7, adding, cancels, 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 cancels. No, sorry, pump the brakes. This is 5. We get this eventually, -4 times 5, -20, 0. Look at that. So this is saying that if we were to evaluate for this function where x is -4, the outcome's 0. Again, if you're not convinced, check your calculator, but lo and behold, wild stuff. And you didn't even need a calculator to solve this. Look at you, smart Algebra 2 student.